Guys, in this video we're gonna figure out the maximum speed of this car. So, to calculate the maximum speed, we need to understand the layout here. The engine drives this sprocket, which turns the chain, which go to this sprocket, which is linked to this smaller sprocket here. And everything here rotates at the same RPM. Then, with this smaller sprocket, the chain turns that bigger sprocket, which is linked to the axles, to the wheels. So everything here spins together, like this. We know that this engine, smaller sprocket, chain, and bigger sprocket is from a scooter. Here, in this axle, is where should be the wheel and tire of the scooter. The scooter is capable of around 100 kilometers an hour, or 60 miles an hour. So, at 60 miles an hour, or 100 kilometers an hour, the scooter is spinning this wheel. Let's go to the whiteboard and I show you how to calculate. So guys, this is the layout there, but I draw the layout here. We have the engine with the sprocket that go to the chain and the bigger sprocket then is linked to the axle, to the smaller sprocket, to the chain, to the another bigger sprocket, and then is linked to the wheel, the final wheel. We're not going to use this red part. We already know that this green circle is the tire of the scooter. And the scooter travels around 100 kilometers an hour or 60 miles an hour. So the radius of that tire is 0.25 meters. And to calculate, we need to use everything in meters and meters by second, okay? So now we have 100 kilometers an hour. We need to convert that to meters per second. To convert, we divide 100 kilometers an hour by 3.6, and we have 27.8 meters per second. We doesn't have the tire, but it's the speed that the tire travels. Then we need to calculate the rotation speed, okay? Which in this case you can think of the RPM of the axle, but to simplify, I'm going to use everything in the international unit. So we need to find the RPM of this axle, which is omega 1. Omega 1 is V1 divided by R1. So V1, which is the velocity of the tire, is 27.8 divided by R1, which is the radius of the tire, 0.25 meters. And then the result is 111.1 radians per second. It's equivalent to RPM, okay? You can think of that, but to understand this radians per second, we need to understand the unit circle. Okay, so here zero, half of the radius is pi, a whole circle is 2 pi. So, but this is a subject for another video. So then we have this angular velocity, okay, which is omega 1, 111.1. Then we need to figure out this V2, which is the speed that travels to the chain here. The speed here is the same of the chain, and of course is the same of the speed of this sprocket here. It's a different size, but the speed is the same. So to calculate V2, we already have omega 1 times R2, which is the radius of this smaller sprocket. R2 is 0.035 meters. So if we calculate that, we have 3.9 meters per second. Okay, this V2. Then we go to discover this omega 2 here. The omega 2 is the same process of discovering the omega 1. We already have the radius, okay, of this bigger sprocket, and we have the speed that's traveling to the perimeter of that sprocket. So omega 2 is V2 divided by R3, which is 3.9 meters per second divided by 0.1015, which is the radius of that sprocket. We have the angular velocity of 38.3 radians per second here. Then, to calculate the V3, which is the tire that is there, the car, it's the same process of calculating this V2. So V3 here, the speed of the tire, is omega 2 times R4, which is the radius of that tire, which is 0.295. We calculate that, we get 11.3 meters per second. So we know that the speed of the tire in contact with the ground is 11.3 meters per second. To convert that in kilometers, we calculate 11.3 meters per second times 3.6, and we get around 40 kilometers an hour or 25 miles an hour. We expect it to be a little less than this because we have the friction with another set of chain and sprockets. We have 4 wheels instead of 2 of the original motorcycle, and the aerodynamics of the car isn't great, correct? So we expect it to be around a little less than 40 kilometers an hour or 25 miles an hour. And that's how we discovered the theoretical speed of the car. I hope you enjoy it.